right, have your homework handouts out if you would please. We had 6 problems to do involving the trig form complex numbers, of course leaving all of our answers in standard form. You chose not to write on the handouts. I guess there wasn't that much room to work anyway, was there? Good. And good. All right. You did write on the handout a little bit. All right. Number 1 said find the 4 fourth roots of 256. What did we have to do first, Jamie?
Okay, the fourth root of 256, or divide by 4.
We try to find all the roots of a number. What do we do first?
We said we multiply by the cosine of 0 plus I sine 0. Then it's that times the cosine of 360 plus I sine 360. Oh, and to the 1/4 power.
Good, we're going to raise it to the 1/4 power. Good, that's the key. But that's only going to give us 1 root, so to get all 4 roots, we have to do the same thing again, you said, but this time, next time, use 360 degrees instead of 0 degrees. And the next time, 720, the next time, 1080. And really, we don't even have to necessarily go into that so much. Each time, and again, I'm too lazy to write it all out every time, and hopefully you were as well. But each time we do, we're going to start by raising the 256 to the 1/4 power, such as you would do on your calculator, which, as we said before, the calculator is a functional instrument, meaning it can only give you 1 value. And it would only give you 1 value for the 4th root, or 1/4 power of 256, and of course that is 4. So there's your principal root. To get the other roots, then, we're going to finish the process from de Moivre's theorem, and that's to do what with the angle now?
Figure out
Remember, de Moivre's theorem said you raise the number, the r, to the nth power.
Yeah, you multiply.
You multiply the theta times the n. So 0 times the 4th gives me an angle of 0. And of course, we knew that was going to be the case. But then when we do the same thing with the 360 times the 4th, we get 90 degrees. And that's really the only time I do it, is just so I can see what the gap is going to be. Because there, from then, I just keep going 90 degrees, and the next angle is going to be 180 degrees plus I times the sine of 180. And then the next one will be 270 plus I sine 270. And then if you were to accidentally get carried away and you're just having a great time adding 90, it's going to stop you because the next one would be 360. And even if you didn't catch that that was the same thing, when you plugged it in, it would go right back to the same thing because it is the same as 0. Now, of course, my first root is always just the principal root because I'm always going to start with cosine 0, I sine 0. It's always going to stay cosine 0 plus I sine 0, which is always just equal to 1. So I always just get
4.
The number, right? The principal root 4 in this case. Here, the whole cosine 90 plus I sine 90 basically comes out to what? 1i, right? 0 plus 1i, so when we distribute, we just get?
4.
The next one, cosine 180 plus I sine 180, essentially becomes negative 1, right? Negative 1 plus 0i, so we get? And then the cosine 270 plus I sine 270 comes out to a 0 minus 1i, distribute, we get? Negative 4i. And again, could you have taken successive square roots? Absolutely. That's a much easier way to do it. Did it this way just for the practice of de Moivre's theorem. I promise you on quizzes and tests I will not give you 4th roots or square roots. I'll give you roots you actually need de Moivre's theorem for, but this gives us good practice on the process. How do we do on finding those 4th roots? All right, figured it out and you got it? All right. Number 2 says to divide those 2 values, and what do we do here, Jamie?
We divide the 9 into 3 and get 3. Then we subtract 35 from the 125 to get 90. Cosine 90 plus I sine 90. And that'll leave us with 1i, and if you distribute, you'll get 3.
And there we go. Good to go. All right, number 3, and I think my chalk is about now. Let me see if I've got more in here. Or perhaps in here. Oh boy. Alright, well, we'll go pink. There we go. In the spirit of Valentine's month. Got the red tie. Walked in today, both of our K-5 teachers wearing pink. They didn't plan it. But, so here we go. We're all in on the Valentine's month. Find the cube roots of 125. Quentin. Careful, you don't divide by 3.
Take it the 1/3.
The 1/3 power or the cube root, the principal cube root, which is 5. I'm actually really curious how this is showing up on camera. I'm not sure. I like the pink on the green, to be that honest. I'm frank with you.
There's some white chalk over there.
Yeah. I might go that route because I don't know that the pink is bright enough to actually show up. You know, not that I want to not be in the spirit of Valentine's month or whatever, but. All right, let's try yellow. I got a nice long piece that should last me for a little while here. All right, make sure the camera has room on the edge of the board. Okay, let's keep going.
The first one would just be 5.
Right.
Then the reference angle is 60. That one's quadrant 2. So cosine 60 is square root 3 over 2. No.
Adjacent over 2. There we go.
Then the sign is square root 3 over 2.
And don't forget the negative here, the positive there.
Negative 502 plus 5 minus square root 3 over 2.
All right, using every inch of chalkboard space. And then the next one.
Reference angle 60 quadrant 3. So it's the same thing, but both signs are negative.
So.
Negative 5 over 2 minus 5 over 2.
And there we go. We get those 3 answers for this one there. All right. I need to play my space better. I got like, a foot and a half of space in the middle. Take up all that room. All right. It's just poor planning. All right. Speaking of poor planning, never mind. We won't get off on a soapbox there. Traffic lights on Whittlesey Boulevard right there near the Columbus Park crossing where Main Street comes up and the Lowe's back entrance is. And it makes no sense at all. I'm like, anyway, people watching on YouTube don't care about our traffic light problems. Number 4, what do we get when we multiply? I'm going to stay with Quentin on this one.
You would get 10, and then you would add the angle, so cosine 3, 15 plus cosine 3, 15. And your reference angle is 45 and quadrant 4. So the cosine 45 square root 2 over 2 is minus square root 2 over 2, but it's negative. So 5 times square root 2 minus 5 times square root 2.
And there we go. Jamie, good to go on that one. All right, Jamie, take number 5, if you would. We're cubing the 3 cosine 50 plus I sine 50.
You're going to actually cube the 3 and get 27. Then you're going to multiply the theta by n, and so that'll be the 50 times the 3 and get 150, or cosine 150 by sine 50. Then you'll look at the reference angle of 30 and then quadrant 2. So it'll be a negative square root 3 over 2 and the positive I 1 over 2. And you'll have to distribute and it'll end up being negative 27 times the square root of 3 all over 2 plus 27I over 2.
There we go. There's our answer for number 5. Quentin going to go on 5. All right, number 6. The 6/6 roots of 64. Give myself a full chalkboard so I won't run out of room. Jamie, start us off.
You're going to have the 64 times cosine of 0 plus I sine 0 all raised to the 1/6 power. And you will repeat that with cosine of 360 and cosine 720 and so on and so forth. But,
Total of how many times?
6.
6. All right. So we're going to end up with 1, 2, 3, 4, 5, 6 6 roots. All right.
And you'll take the 6th root of 64 and get 2.
Good. The principal 6th root of 64 is simply 2. So that's how we're going to start with our r each time.
For the first one, you'll still have the cosine of 0 plus I sine 0, which will be 1 and we'll get 2. Then for the next one, you'll get cosine 60 plus I sine 60. Next one is cosine of 120 plus I sine 120. Next one is cosine of 180 plus I sine 180.
We can clearly see the 60-degree pattern at this point.
Cosine of 240 plus I sine 240.
I'll write it so I don't mess something up. And the lazy side of me is like, I just want to write 240 and move on, but you know.
Cosine of 300 plus I sine 300.
All right. Now what?
Now we're going to take the cosine of all the betas, and for the first one, for cosine 60, it'll be 1/2 plus I plus the square root of 3 all over 2. And you'll have the square root to get there's 1 plus I times the square root of 3 all over 2. No, not 2.
Right, because you're distributing 2 times 1/2 is 1. 2 times I squared of 3 over 2 is I squared of 3.
Okay. Then the next one will it'll also have the reference angle of 60, so it'll be similar.
So it's going to be the same numbers,
Except it's
1 and I squared of 3, but it's in quadrant 2. So the cosine being the first part needs to be
negative,
and the sine being the second part.
positive.
All right.
For the next one, the reference angle will be 0.
All right, so I can't just put an I or a 1 and an I squared of 3 on this one because it's not a 60-degree angle.
It'll leave with a -1, and so it'll be -2 for the answer.
Right, so we have a -1 plus 0i. Another way to get it, cosine 0 plus I sine 0 is 1. Then the opposite, or 180, would be a -1, so -2.
For the next one, the reference angle is going to be 60 again.
So again, a 1 and an I squared of 3, but,
Quadrant 3, and
so
both negative.
negative. All right.
And for the last one, it's also going to be a 60 reference angle, but it's in quadrant 4.
So 1 and I squared of 3, first part is cosine, that makes it,
Positive,
and the second part sine,
negative.
and there's the 6 6 roots. Did we get them all? Any questions at all on complex numbers in the trig form? All right, we'll go and clear your desks except for a clean sheet of paper, a pencil, a calculator. Clean sheet of paper, pencil, calculator, everything else away. First last name at the top of that paper now, along with today's date, which is, oh, my calendar fell down. It's not January anymore. I turned that page. February the 4th, 2/4/22. 2/4/22 today's date. 24. 22 today's date, and this is quiz 29. Quiz 29. Very little bitty, short, not scary quiz at all. Just 4 problems for you to work. Perform the indicated operations, and be sure to leave all answers in the standard complex form. We'll pause, we'll end the video here, and when you're done with your quiz, go and start part 2 of this lesson.